So the fork is for creating child processes. Okay, it's essential for creating child processes. And I explained the child processes the last time. You would want to go to the recorded sections and then watch it again to understand what a child process is. So it is essential for creating a child process. Okay, and then when the fork creates the child processes, it uses the execve to what to execute the program in that child process, and then it returns the status back to the what to the parent process. So I really don't want to go back to this because it's in the heart, it's in the concepts. I really don't want to go to it so that we waste my time on it. So for now, let me just try and tell the users. So let's say even in your shell, you have to what take a command, and the command is ls. So the command comes to the user, and then the command comes to you the computer operator, and the command is ls. What you want to do is that you just don't what execute this ls program. After finding this, you just don't execute it. Okay, you want to open this program in a what in a new processing image. So let's say this will be the shell. So let's say if shell is here and shell finds the program, shell finds ls and it wants to execute it. Shell must still continue working because after this one finishes executing, we need our shell back. So we don't need to this process to be what interrupted. That is when so this instance of what of the running program of shell, this instance of it. Okay, what happens is that whenever you use fork, okay, fork basically creates another process, and you get a duplicate of this process. But this becomes the parent process and this becomes the child process. So this process will wait for this program ls, to finish what executing before it continues. Good. I have that one I have the code already, so we'll just go to it. So let's say let me explain more into it. So so you want to continue managing your shell even after running ls. You still want to continue your shell to still run because that is what is handling what the ls program. So it takes no parameters. It takes no parameters. Should I say now? Yeah, it takes no parameters. You don't pass any parameters to fork. You use it just like this. Okay, and then it returns in the return is also complicated. So let me just write it. I will explain all of it. Don't worry when you don't understand. So what fork does is okay. In the parent process, when you call for fork, in the parent process, okay, what happens is that it returns what the process ID. It returns the process ID of what of the child process or the newly created process. And you understand why it should return the process ID. I explained to you why we need a process ID to be able to keep track of what of our running what processes. And then the second one is okay, in the child process, it returns zero mostly. So this is in the child process. In the child process, it returns zero for what? Hello guys. Zero for, and then it returns -1 if an error occurs. If an error occurs, it returns -1. So yes, let's go into our code and let me demonstrate how shell and the fork was used. I think this one was back, so I would have to just move it here or copy it fork into our allowed functions. Wow. So yes, basically. So we have fork. Okay, let me clear the screen. I think no, I will not implement it. I think it's already in the what in the concepts. But let me just review what is inside it so that I'll not explain. It's already in the concepts with a better explanation. We can't waste much time here. Very soon we need to start building our what shell, and then we don't want to waste much time. So this is what's happening. Let me run it for you to see what is happening inside the what this file. So you can see from here in our codes that what, first of all, this is the program's parents ID. We can say this program, okay, we can say this program is what is a shell. All right, so is a running, this program is running, is a shell. We did not use execve here, but we use it. And then you realize that at here we called fork. Okay, and then the reason why I assigned it to PID is because it returns a process ID, and then I want to keep track of that process ID. So if the process ID it returns is -1, I want it to print what, fork failed. So you want to keep track of the process of what, of the newly of the instance of the new process. Okay, you want to keep track of that process of what, of the new program you're running. If it is ls, if it is make directory, you want to keep track of it. So if it is equal to -1, then it means that what, it failed to what, to create that what child process. So it should return what, -1 if the what, the fork, if the forking what fails. So let's run it. Okay, so if in this is in the child process, okay, so if the child process or the process ID, the new process ID is equal to what, is equal to 0, then it means that what, the child process was created. So it will give you the child process what, ID. If it is less than 0, then it means that what, we are not, we are dealing with the parent process, because the child process is always what, it's always 0. The pi the process ID of the child is what, it's always 0. So once it's more than 0, then it means that it is what, it is what, it is a parent process. So let me execute this to illustrate what I'm saying. So can I use GCC flag? Let me just compile it. Okay, first. Um, so let me just say for. So let's take note of something. So yes, so this is the program's parents ID, right? So before fork, I had what, 1, 2, 3, and then it's create. So this is program's ID. So it means that after before the fork, this was the ID, and after the fork, this was the ID. So I want to keep track of something. We are printing 1, 2, 3 in the program. We are printing 1, 2, 3, 4, 5, 6. But I realize that here it's printed it twice, meaning that what, it has created a duplicate of what, of that instance of the running program. So if you're expecting 1, 2, 3, 4, the moment you call for fork, it it gives you what, a duplicate of what, right after you call the fork, everything after that will be what, will be duplicated. The program, the process will be what, will become 2. So that is why we have what, 4, 5, 6 here appearing twice, because we called for fork. And don't worry about that now. When I use the execve and then the wait to implement it, you understand it more. And that one to have the code, so we will not waste much time. So this is, let me push this code so that you go through it when in your meantime. If you don't understand anything, you can just alert me or push the codes for ChatGPT to explain, as I always say. So fork system call function, all right? System call. So let me push it. So yes, let's go back to it. So please, is anyone confused with the fork? If you are confused, if you don't understand anything, you can ask your question before we move on. I think we've already spent 1 hour 70 minutes. Wow, I thought we'd be done within a short time, but it seems time is really going. Anyone, any question? Any question? Anyone wants to say anything before we move on? I hope you guys can hear me though. Can everyone hear me?
Yes,
Yes.
yes, we can hear you.
Yes, so are you guys sure you understand what the fuck is doing here? Because I feel like I'm missing something. Did I explain everything concerning fork? Anyone want to add anything to fork? What fork does? Those who did it, what fork does. So I assume that what. So why do we need fork? Why do we need to use fork? Okay, I have explained that already, but let me touch on it again. Okay, so when the shell wants to execute what the program that it founds, it needs a different process image for it. It can't execute it in the process of what of the shell. We will come to that and why I'm saying that. So the reason why we need fork is to be able to what execute our program in a different process image. Good. And then we want to create a duplicate of it so that we can have our child process. Always remember that what the shell is what the parent process. I explained it the last time. I will not touch on it again. The shell should be your parent process, and the other programs like the commands should be your child process. What just happened? No. Wow. Wow. Okay, so I'll move on and deal with this later. Let me close it. Push the files. Wow. I'll move on and do with this later. For now, let me try and open it down so that by the time I come back, it's already open. So yes, so let's move on to so let me come back to the execve. Okay. So the next one we want to talk about is what? Is the execve. I think this one to ALS touched on it, so we don't need to go much into details. ALS touched on it, and then so basically, yes. So the execve is used to what execute the new program that what the shell finds. Okay, after the shell has found the ls, the um what again, the make directory, the task. After it finds it, what it does is that what it executes it, or it opens that program with what the execve. So let me try and explain it. So the execve, okay, it takes. Let me write the signature first. So I think I might have forgotten how to do it. So, okay, sorry about that, guys. So we have execve. Should I type it? No, this is okay. So we have execve returning an integer, and then remember that most of the system calls always deal with what the path name, a string to the path name. That is the location of the file that you found. So let's say the path name, if it was ls, okay, we will have to include the path of ls to what? To the execv. So that's the first parameter it takes. Okay, the path name. That is where is the program, where can it be found? And then it takes what? It takes the arguments. So remember I was saying something like when the user enters something like, so let me just write this down before I go to it. It takes what? The arguments. Remember, it's what? It's an array that ends with what? Now. So I explained this. So it's a lot. And it's a lot because it's very important. Um, but is it the environment p constant? This is constant, right? Hello, and please, guys, is this constant? Is this? I think so. I think this is also constant. Let me refer to my notes. Let me see. Okay, so it's a lot. Let me just type it so that everyone sees it clearly. It's a lot. And it's a lot because it's very important. So let's see, it's an integer and then execve. So it's a constant. uh, Happening. Okay, Okay, then we have car constant at V. Please, if I make any mistake, someone should prompt me. Those who have already done it. I hope Ami is still around. So, yes. Let me separate this. So basically, yes. Don't forget your um. Yep.
execve,
Okay. Thank you very much. Argument vector, not just arguments, right? Thank you very much. Good. So, please, is that all? The one who gave me the argv. Yes, 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 yes. I think so. So this is argv, this argument vector. Okay, and this is what the program. So let me see if my my this one it didn't it work. Wow. So guys, I think we have to do it another one and wait for this one my Ubuntu to finish loading. So let's do it. Let's find. Let me move it from here. Let me move it from here. Move to. So for now, I'd have to use another. Let me use Vagrant to explain. I think I have the file in Vagrant. So let me use my Vagrant to explain the execve. So you would want to. So as it's loading, let me talk about the parameters and everything. So you'd want to what? You'd want to indicate the program. In this situation, in this shell implementation, we want to what? Indicate. So in the shell implementation, I think if you want to run, let's say ls, okay, let's say the path. What is the path ls? Is been ls, right? Oh. So let's say you want to indicate the path. So we have what? Ls. I said that in our codes, in our shell implementation, we will not be what? Be indicating it ourselves. We will not be assuming it for ourselves. We are just going to what? Implement everything. So first of all, we want to take what? Being ls as what? The path name to what? To the program you want to what? Run. And then let's say the arguments. Okay. So I was explaining that let's say the user enters something like ls, the user enters something like ls and then hyphen L. How are you able to tell that this hyphen L is what? Is an argument. And so the program should treat it what? Differently. Or shell should interpret it differently. And I was saying that we can use string tokenization. But before we come to that, know that this is what the argument vector there stands for, right? The argument vector takes a lot of um, it takes it takes a lot of argument depending on what you want to accomplish. But for now, let me just explain that the argument vector, okay, it's an array of strings representing the command line arguments of the new program. Okay, and the last element should always be what? Now. Let me indicate it here. The last segment should always be now. There is a reason why. I'll come to that. And then this envp here, okay, is means environment variables, right? Environment variables. Okay, it is an array of strings representing the environment variables of what? Of the new program. For now, ALS made us use now there because for now we will not be using it. If you are not able to implement it and you use now there, some of your checks are still going to check, but you need to what? Handle it. So let me. I think my vagrant has finished, so let me go into it. So, but I have some problem here, so it will take a lot of work. That's what I wanted to use the Ubuntu. I have not created the aliases here, so I have to individually, find where the files are. Wow, how am I going to find them? Let me go back here. Okay, so cd copy. Okay, let me zoom in small for everyone to see. I think it's in cd my projects. No, cd repos. Cd simple. Is it here? No. Wow. Um, cd. Do I even have it here? Wow. Guys, what is the command for finding? Is it G? Is it? Can I just use find or let me? Someone should help me find this program. Like it's called. But let me just go and clone it from my GitHub. I think that one is better. Yes, let me just clone it from my GitHub. This will open directly to my GitHub. Yes, my commits. Mm, Let me just clone it. A moment. Let me confirm if the, this one is done. Okay, this is done, but okay, so this is done. But I have to close and open it again. So, but for now, let me just use it to illustrate the execve. So CPS, yes, CD lessons, CD charcoals. Okay, let me just find it. No, it's not clear. Let's see this and push. Okay, so it is. We have it here. Thank God we found it here. So this is it. So let's say we have okay. The first the first argument it takes is what is the path name. And remember how in writing the name, this is what I did. Right, where is this? This is what I did. I wrote, but in trying to what implement it, this is how I did it. So it first takes what? So as you can see here, I've tried to include a path here to tell it that this is where you can find the program. So the path name is basically you trying to tell the what it that what this is the path to the program you want to execute. Okay. So let's say we all know where and in our simple shell implementation, we all know where what our programs are. We all know where they are. So you just want to what indicate that this is where it is. And it's what this is the name of the program. And when you go there, okay, this is what I want you to do. When a person enters, these are arguments, like arguments someone can just what pass to the what to the program. So first of all, your first argument should be what in the array, your first item should be what the name of the program and then the argument the person can pass to it. All right, I don't know if that makes sense. And then the last item, always make sure that it's what is equal to now. The last item is now. All right. And then for now, we will not use what the environment. Okay, we will not use the environment. So for now, let me just execute, run this program, and you see what it does. So time is so before execve, what? No, let me compile it again. GCC execve. Let me run it. I'd have to restart this again, but let me use it to explain the execve before. It's a bit slow. I hope by tomorrow I have the problem fixed. Okay, so this is what happens. You realize that it says that what cannot create directory shell file already exists. So it means that I'm trying to use the execve to open a program. And the program name is what? Make directory. That is the mkdir. And then it's trying to tell me that I can't what? Create the shell because it's what? It already exists, which is true. As you can see, we have what? Shell here. All right. So you want to implement this in your shell. So let's make changes to it so that you understand it more. Let's make changes to it. So let's say you want to create a directory called, we want to make a directory called um, directory. All right. So the arguments, if you are going to make a directory, the arguments you pass to it is what? Is the name of the directory, right? So that is why I made it second, so that to tell the program that after the make directory comes, whatever comes after it is what? It's an argument. So it's supposed to what? Operate on it, right? So that is basically what is happening there. So let me compile it again and let's see what happens. So when we list our programs, you can find what dir here. All right. So basically, that's what the execve does. So it makes what? It makes the program simple. So that's why it's very important and it's very crucial in what? In your shell implementation. You can't implement a simple shell without using what? Execve. Right. So please, when you are free, make sure you get time to go through everything again so that you're able to understand what is happening here. All right. So for now, this is how it works. So I'll push it. I'll copy it and push it there so that I know. I think ALS have a concept on the execve. So if you have any problem using the execve, you can just what reach out and I'll help you with it. So let's move on.
Sorry, I have a question. Does it mean that for that execve, it actually created a directory?
Please come again.
I'm trying to understand what you did over there. You changed to shell. You changed the shell to dir. So I want to understand what happened. Sorry, I was having network issue.
I can't really hear you well.
Can you hear me?
Yes, please talk.
Yes, I said I was having network issue, so I didn't see what you did there where you changed the shell to dir.
Oh, okay. Yes, so it's basically in the codes. This is it, dir. I changed it from shell to what? Dir. So it's just simple as that. I just changed the argument. So let me, yes, good, I'm coming. So let's say, what are the steps to creating a directory? And please, I want you to carry us through. What are the steps to creating a directory?
Is to they use the mkdir,
Mm-hmm.
then the name of the directory.
Good. So we understand that this mkdir is a program, right?
Yes.
It's a program that can be found in what? In the user um,
User,
bin, right? Yes, we
yes,
understand that
yes.
it's a program that can be found here. Good. So now that we have solidified that understanding, let's go back. So it means that what the execve is what? So we first what? Enter this command and then the name of the file, the directory we want to create comes next, right? So
Yes.
So yes. So this is the work of what? The execve. That is what it does. It first take the first
Okay.
it takes the first argument, like the first thing you pass to it, the mkdir, uh, as what? As the
Yes.
command. And it takes what follows as what? An argument. And it does it for you. So let's say if you wanted to
Okay.
list files, so let me go into it and explain it more into details into it. Let's say if you go here, this is what happened. I placed the name of what? The program here, right? And then I passed the
Yes.
argument to it.
The argument.
But before I did that, I tried to tell the what? The execve that okay, this is the path name. This is where you can find this program I want to run. So it basically does the main concept of shell, going to find the program and what? Executing it.
Okay.
So that is what I
Yes,
was saying, that
that
it is very crucial. It is what plays the most important role in the implementation of our shell. Because without the execve,
yes.
how are you going to find the program and how are you going to execute it? Good. So let's use ls. So right now, I want you to help us with, in case you wanted it to what, execute the program ls. How would you have done it? Let's go. So help us.
You
I have a question.
Okay, please write it down before that we move on to your question. Okay. So okay, I hope you're
you
okay.
change the partner. Okay, yes.
Yes. So we do what? Yeah, I'm
You
listening
change
to you.
out
I
to
hope not.
LS. Hello?
Yeah, I can hear you talk.
I said you change the MKDIR to LS.
Yes, to try to tell the exec that what our program is what called ls, right?
LS, yes.
Yes. Then what else?
Then you change that one to LS, the
Okay.
MKDIR.
Yes, to ls, and then
Then
if you want to pass any arguments to it, we
maybe
pass
you can
it to.
call this L. Yes, maybe you can call it L.
Yes, we can say it's what the argument is what. So basically, what our brother here is trying to tell us is that this program is supposed to what long list what the files.
Yes, the
Good.
file.
So let's see if it works fine. Trying to compile it. Yes, then we all env. Why did I even name it env? Okay, I think it's a mistake, but it doesn't matter. So yes, so our what
Yes, it did. Yes.
yes, basically it did what we wanted it to do, right? Good. So
Yes.
that is how the exec view works, and it's very crucial. And I don't want to be touching them because I explained in the last section that we should. I know that I'm not going much into details because I'm just introducing you to the functions. Okay. So in the next section where we are actually going to start using them, then we will try to go much into detail. But I don't want this to waste my time because the functions are a lot. That's why I was like, guys, please go through the resources. Guys, please go through it. So thank you very
Okay.
much. So please, I want with a question. You can ask your question.
Okay. I was asking if you used the path name and then you listed. For example, if you used the bin instead of ls, you use the mkdir. And then inside the argument, while you're passing the constant argument, vector, you pass ls. Will there be an issue when you are
Okay. So please come again.
compiling
Let's
your code?
implement what you're asking. So you say we pass. What do we do here? We pass just
mk,
Ben.
yes, mkdir.
Okay. MKDR. Like this.
And then in the argument vector, instead of mkdir, you use the ls, and then you try to run your program.
Okay. So we should leave it like this and run it, right? That's what
Yes.
I'm trying to say.
Mm-hmm.
Good. So
Yeah.
I'll to okay, let me just run it for you to see. So basically, let me explain the logic behind what our sister is saying. So basically, what you are trying to tell is that you can find a program here, and the program is called what? MKDIR. Okay. But but okay, the program name is what? LS. All right. And then the argument is what? Good. So it's a very good question. There might be situations like that when someone what the user will enter a command like mkdir and then they list ls and everything. So let me illustrate what is going to happen right now. First of all, let's run this program. Okay. So yes, invalid.
Invalid.
Good. So it says we should try ls. It means that we've passed arguments to what? To I don't but I don't know why we are doing this thing in the first place, but we want to, for in order to what, to check for situations like this, You need to check for what? The returning, how do we say? We want to, let me see if I can implement a statement here to check for what we just did. So let's say, mm, okay, do you know the problem? Execve does not return anything. That is going to be the problem. So I don't know how I'm going to. On success, it returns the newly what? The newly program. It replaces the current process. When, let's say, let me undo this error. Okay, let me just undo it and then let me explain something to you. When this execve is successful, this is what it does. Let me clear the screen. What's the name of our program? Let me compile it again. When it's successful, okay, this is what it does. It replaces what? The shell, the shell's process image. It does not replace the process. It replaces the process image. Let me explain. When we run this, okay, this is what happens. Everything there stops and then it comes to what? Execute our program for us. And then we get this. That is why we need to make use of what? The fork and then the wait. I'll explain that. So basically, what the execve does is it just finds our program, it runs it. For now, just understand it like that till we start what building the simple show like from scratch. For now, just understand this. So that's what happens. And mind you, I always say this: you are not going to explicitly type these things in your what in your code. These ones, the part name, you are not going to, because it would have it. So if in situations where the user enters ls, you want to say they should do this. If the user enters mkdir, how are you going to handle that one? So what you want to do is that you want to take the command and then put it here. You're right. You want to take the command and pass it to what? To the execve. That's what basically you want to do. Whatever the user types, you first want to find the path of it. You want to, when the user enter ls, you want to what? Check in the open operating system if you have a program called ls. If yes, then you what? You want to work on it. You want to operate on it. You want to check if the user passed any arguments to it. If not, then you want to what? Run the program as it is. If they pass on, you want to take it into consideration. That is when string tokenization comes into usage. So let's move on. Time is, I don't know, we spent my time. It's almost 2 hours. And I don't want to, I have a time set. So I don't think you can use today to go through all the functions. So let me write did I write the returns for us? No. So let me add the returns. Okay. So on success, let me say it does not return any number. Okay, it replaces the current, process image. If you don't understand anything, you can ask me or chat GPT to explain what process image is. I think I've explained a lot of times. So on failure, okay, it returns a negative one. Okay, you can use Perl to print that. It returns a negative one. You can use Perl to print that to the screen. Okay, so let's move on. Let's move on to the next function. Oh, there is a bit of noise here. I think, okay, I want to end the meeting anytime soon, and I wanted to explain the weight, but since it's in the what, it's in the ALS resources, and our brother was talking about data, convention. Let me explain exit. Okay, then we have to end the meeting, and I think I wanted to explain weight. But let me touch on it. Okay, basically what the weight does is, okay, after you use fork, okay, you see that there is a new was process image. Okay, before I come to exit, let me go to that my program I wrote to satisfy everything. This is what is happening here. So I'll just touch on the weight. I'll not explain it into details because it's already there. So V, how did I even name it? Few, yes, few. Um, so this is basically like a simple shell, right? It is not a simple shell, but it is to explain what is happening in what simple shells. What do I mean? So when you look at these codes, I implemented execve. I have execve here. Execve, where is execve? I didn't use it. I don't know. Did I use execve? I don't know. Yes. Yes, I use execve to what? To open the new program. So this is it. Because I needed to open the program called ls. So you realize that at here I said if the newly opened program is equal to 1, -1, it means it failed. So what I want to do is I want to print error, failed to open new program, and I want to exit it what status what 2, or the convention as our guy was trying to say, with what, with 2, with status 2. Okay, I've explained that. So when you so after using the execve, I said it should open the program and it should return what? Whatever. It should return its failure or success to what? The new program, because it's the new program I'm trying to open. So if the new program is equal to -1, then it means it was not able to open, it failed. Or else, so it means that if the new program was actually able to open, then I want to print and I'm waiting for child. It was a very funny analogy, and then I got. So this is let me run it to explain it more. So in our statement here is if it fails, if the execve fails, it should print what? Fail to open new program. If it does not fail, it should what? It means the program has been opened. So then we want to work on the new open program. So the new open program is doing what? It's going to print what? And I'm waiting for the child. So basically, let me just run it for you to understand what I'm trying to depict here. So is it few? So yes, basically, this is what happens. It's a lot, but it explains processes. Okay, so this is what happens. This is what the program. Let's say this is shell. Shell is running. So in the shell, we have what the process ID to be what 49459, right? And then the reason I used I am child here is to say that after I use the fork, okay, so after using the fork, it creates what I said that the fork creates a child process. So the child process I did the child one, I created 5 instances of what of the running program, like let's say 5. So let's say I created 5 different processes. And what happens is that the first process waits. The first process will be what will be called child one with the ID what 49460. It waits for what? For the program waits for the first process to finish running. Then when it's done, it handles it over to the second process. Then when it's also done, it handles it to the third process. It does that repeatedly to what? To the all finish running. And they return their exit status to what? To the parent. Then the parent takes it on from there. So whenever you see statement like I am the father, it means the parent is running. And whenever you see statement like I'm child one, it means what? The first child process is what? Is running. And in our course, I said the child process should what? It should long list all what? The files. I used the ls, the execve, I used ls dash l. So this is what happens. It lists all what? It lists everything. For now, just keep in your head that it's listing, right? So a list, okay. After a list, then it finishes. Then it's finished. So it opens another program. That is also what ls. And then it says I am waiting for child one. I think I made a mistake here. Yes, the parent is waiting for what? The child one to finish processing. After it finishes, it says the child one process exited with what? Status 0. It means it's run successfully. Okay, so it will return the what the ID to the parent. Okay, so then it said my child one is done processing. Then it gives you the what the process ID of the child one, and it says I am the child two. I am starting my operation. So that's what basically happens. So they all wait for that to finish. Then it continues. Then it continues to what to the child process 5. So this explains situations like let's say you have to run a lot of commands or like you have to open a lot of programs. Okay, and it's all in the concepts. Please take time, read through, If you don't understand anything, ask ChatGPT or you can come to my domain. I'll explain it better to you. Basically, that's what's happening. So it's simple as that. This program has been able to create 5 instances of different programs. This simple code. So that means if you take time and then you're able to implement it, it will become very easy, especially with your shell few.c. Right. So this is the code. So I'll push it and then you send it to ChatGPT to explain it for you if you don't understand. Or it's already on my GitHub. So let's move on. So basically that's how the fork, execve, and the wait work together. Okay, so the wait is basically like wait for the other to finish before you continue. So we have about 7 minutes for the minute 20. So let me explain exit. Okay. So in one of the requirements, the checkers, we want to make sure that what we are exiting the program when we are supposed to exit them. So please, the guy who asked about the conventions, are you here? Are you here? Hello? So we assume he's left the meeting. So let me explain what this means. All right. So the exit is a function. It's part of the standard library, right? It's part of the standard library. If I want to include that. So what it does is it returns void. It doesn't return anything. It's just like um one of these statements. Which statements? I don't know. Just like the wait, it also takes what status. It takes status as what parameters. So if you have exit in your code like this, so let's say how should I explain it? So basically it's exit status, exit and what you put in the exit status there. It's very serious, right? So as situations you want to exit your program, right? So let's say there are some situations when you encounter an error, you want to exit the shell. The shell shouldn't continue running, right? You want to exit the shell so that what you return the status to what the user if their program was successful, if it wasn't successful. And this is what the function we are going to use. It's a lot, especially with their conventions, right? So I wanted the guy here to help us if he has learned most of it. But for now, I can just say the exit also just like every other function. If you say exit zero, it means that the program that you open what exited successfully. But if you want to say exit -1, it means the process was what interrupted. So you have exit status like I don't know whether in one of my codes you saw that I exited with what was it 19? Yes, you can exit with. There are a lot of status to it, 99. And then before that, when we start building our simple shell, we'll make use of the ALS test suite, right? It tells you when you're supposed to exit with a certain status. Like in this situation, it's supposed to exit with status 0, it's supposed to exit with 1. So if you go to your errors, I'm not allowed to show you um my how do we say it, my intranet. But Julian lays emphasis on the fact that, and then they don't tell you till the deadline is near that you know you're going to open your your review, QA review, and then you're going to see that Julian was expecting that you exited your code with what 99, but you exited with what 0. So then it means you have to fix that. So when you start with the ALS test suite, then I'll try to use it to explain. Okay, it will tell us where we are supposed to exit with this code and this code and this code, and then we will have it what easy. So time is almost up. Let me try and implement the exit in codes. Let me find my notes here concerning the exit. So know that the exit status does not really return anything. That is why I have void here. It just terminates the program. Whenever it is exit, it just terminates. But it terminates with what a condition. So let me find the program and let me try and explain the exit and touch on the other. I think you guys have the other functions, right? So it means yes, the internet has been opened to us already. So um, where did I even use exit? Have I used it before? If not, let me ask. How do I use exit? Let me just demonstrate it with any of my codes. Let me demonstrate it in. I think I used it somewhere. I just don't remember. and I've honestly forgotten the way how I can use it here for us to see. So let me find a program. Okay. Let me this program was it Python? So I can't use Python. So let me go back to um any of my programs here. CD back. Okay, so let's see. Yes, CD my project. Actually, I can't temper my project because I've honestly forgotten why some are even working back. So I can't temper the file, but I can explain situations when we can use exit with it. This is registration forms. So basically what this does is, let me try and what this program does is a C program that is just like an implementation of what? Of an online registration form template. So it does what every other form does. It asks for your first name, it asks for your other names, the month you were born in. So yeah, basically if the year or anything is wrong, it tells you that is wrong or any invalid year format. Basically, yeah, that's what it does. So let me get into the code and explain situations where you can use exit. Let's say after the user enters their year of birth, okay, I want to exit the program right after they enter their year of birth. But so I can use the exit right after the condition where I wrote that it should ask for the year. After it takes the year, it should exit the program. Right. So this program exits when um invalid. I'll explain. This program only exists. It's a lot. It only exists when I think if I don't take time to go through it, I will be caught in a loop. So let's say enter a choice. I'm a male. All right. Your country, city, address, telephone. Okay, so let me say submit. So right after the user presses submit, I want to print something to the screen and exit the program. Right, but I'm not just exiting. Gillian is laying emphasis on the fact that exit with a particular code, depending on what happened. If it was an error, indicate it. If it was like the fact that a program has finished running, indicate it. And all of these ones are what brings us to the different conversions. So take time. Let me submit it so that the program ends. Yes. So let me go through the code and try and implement exit right after the user enters their name. So let's say, I think it's been long since I read. No, it's not been long, but I don't remember much about it. Forget about this. I just want to implement the exit. Yeah, okay, I actually did it. So yes, I think I used exit here because it's a very good practice. I exited with code zero because I tell you to right after. Let's say it's an error. I'm not supposed to exit it, but I'm not done with the program, right? I'm not done with this project. So when I get them, I'll change all these things. So basically, if I wrote a program that when the user enters their name and their name is what exceeds 50 lines, like 50 characters, basically like on a normal circumstance, normal human beings have less than 50, right? And I was trying to save memory space here. So if the user enters their name and the characters exceeds more than 50, it should print to the screen. It should print that name limit exceeded. Please start over. And after that, right after it prints the error, it should what exit the program. Right. But this one, I explain it doesn't exit the program actually because it's a loop. It's a loop. It exits that part of the loop. So exit is not used to exit this program. You can use it to exit loop. It depends on how the context you want to use it. So after it prints this, it exits to say that it was what successfully what did what I asked it to do, then it goes on to the next thing. So basically, that's what exit is about. So instead of using situations like return, break, make sure that you know when to use exit. It's not every time you just want to return. Like after you print the error, you want to return one. In short, like why are you returning the one for like you want to exit the loop because shell is actually in the loop. Yes, it's supposed to be in a loop. So that is basically what the exit function does. So I will find a cheat sheet of exit and the various status codes and what they return, and I will send it into the group for everyone to gain access and read through so that they know exactly when to what exit their loops and then their programs. Okay. So yes, any questions? Any questions? I think I would have to bring the meeting to an end now. The next meeting, we will start with how we to use the functions. We'll start building the shell in the next meeting. The next meeting is tomorrow. It's tomorrow. Tomorrow we will start implementing these functions, and it's going to be a long section because we are going to be doing a lot. So I'm thinking of maybe about 3 hours, 3 to 4 hours, and then we are going to start with the basics. In case there is an interest, things like LS, MK, that what are we going to do? We are going to implement it in what? In codes. So that is what we have tomorrow. You don't want to miss it because yes, I will not talk plain. So any question? Any question?